Welcome all my dear students of SIBC class. This is lecture number 6 of physics paper first, that is mathematical methods in physics first. In previous lecture we have studied complex algebra by using Argand diagram. We also studied some important problem related to Argand diagram and complex algebra by using an Argand diagram. Now in this lecture we are going to see de Moivre's theorem. And some important problem related to de Moivre's theorem like this, along with some homeworks. Question may be asked on this de Moivre's theorem like this: state de Moivre's theorem. State de Moivre's theorem. So we have to consider here only statement, and statement of de Moivre's theorem is very simple, like this: cos theta plus I sin theta bracket raised to n is equal to cos n theta plus I sin n theta, where n is power. This n is power. In previous lecture we studied Euler's formula. What is that Euler's formula? Cos theta plus I sin theta is equal to e raised to I theta. Now, by taking the power on both the sides, that is power of RHS and power of LHS of Euler's equation or Euler's formula, we have cos theta plus I sin theta bracket with n, that is n power of this is equal to e raised to I theta into e raised to I theta into e raised to I theta, like this, and this is up to n times. This equation we may write in brief: e raised to I theta into n. That is meaning of this e raised to I theta bracket out of bracket n is nothing but e raised to I theta into e raised to I theta into e raised to I theta n times. Okay, this is again we can write by different way, that is we can write like I theta n, or we can write like this: e raised to I theta n. Okay, or okay. Now this gives us, according to Euler's formula, cos theta n plus I sin theta n, or cos n theta plus I sin n theta. And from this we can write cos n theta plus I sin n theta, which is nothing but the power of n power of cos theta plus I sin theta, and this is nothing but a very simple statement of de Moivre's theorem. Now solve some problem. We are going to solve some problems related to this de Moivre's theorem. First problem: transform z is equal to 2 root 3 plus 2i into polar form and exponential form. This one. So in order to solve this, obtain the solution like this. Let z is equal to 2 plus 2 root 3 plus 2i. Note that here this complex number is in rectangular form because 2 root 3 and 2 are the rectangular coordinates. Okay. Now compare this equation with z is equal to x plus iy. Comparison gives us value of x is equal to 2 root 3 and value of y is 2. Value of y is 2. Now, in order to transform this rectangular form of complex number into polar form, we have to obtain the modulus and phase angle. Modulus r and phase angle theta. Therefore, modulus r is nothing but square root of x square plus y square. Substitute the value of x, that is 2 root 3 and y is equal to 3. In this equation, we have 2 root 3 square plus 2 square. Solve this term, we get 4 into 3. 4 is a square of 2 and 3 square of root 3 plus 4. Solve this term, we have 12 plus 4 square root or square root of 16 or 4, where 4 is the square root of 16. In this way, we get the value of r is equal to 4, that is modulus. Now we have to obtain phase angle or argument, that is theta is equal to tan inverse in bracket y upon x. This is derived from tan theta is equal to y upon x. Now substitute the value of y and x, we have tan inverse, value of y is 2 and value of x is 2 root 3. Here 2 and 2 get cancelled with each other and we have tan inverse 1 upon root 3, which gives us the value of theta is equal to pi by 6. In this way we obtain phase angle or argument theta. After obtaining the value of r and theta, we have the polar form of complex number. Polar form of complex number is like this: z is equal to r in bracket cos theta plus I sin theta. Substitute the value of r and theta in this equation. We have 4 cos pi by 6 plus I sin pi by 6, and this is nothing but the polar form of complex number. Okay. Now in order to obtain the exponential form of the complex number, again we have to express this rectangular form, that is z is equal to x plus iy into exponential form, and that is nothing but r e raised to I theta. Again substitute the value of r and theta, we have 4 e raised to I pi by 6, and this is this equation represents the exponential form of complex number. In similar way, we can solve another problem by the same method or by the same fashion. Second problem is transform the complex number minus pi I into polar and exponential form. Again, in order to solve this problem, let the solution z is equal to minus pi I. Write this number into rectangular form. We have 0 minus pi I. Suppose this is equation, and as usual we have the general form of complex number z is equal to x plus iy. Suppose this is equation 2. Compare equation 1 and 2, we have x is equal to 0 and y is equal to minus pi. Again obtain modulus r and theta in order to express this or transform this number in rectangular form into polar and exponential form. First, r is equal to square root of x square plus y square. Substitute the value of x, that is 0 square. Substitute the value of y, that is minus pi square. Solve this term, we have 0 plus pi square or simply pi square or pi. This is the value of modulus r. Now obtain argument of phase angle, and that is from the equation tan theta is equal to y upon x, or theta is equal to tan inverse y of x. Substitute again the value of x and y, we have tan inverse y square minus pi upon 0. We have tan inverse infinity. Remember that to any number when we divide by 0, then we have infinity. And this infinity, this equation gives the value of theta is equal to pi by 2. Then again substitute the value of modulus and argument in polar and exponential form. Again for polar form we have z is equal to r in bracket cos theta plus I sin theta. Substitute the value of r, that is pi, and theta, that is pi by 2 plus I sin pi by 2. And this is nothing but the polar form of this complex number in rectangular form. By the similar way, we can write or we can express the number, complex number z plus x or y into exponential form r into e raised to I theta. Again substitute the value of r and theta, we have pi e raised to I pi by 2, and this is the exponential form given complex number. Okay, now see one more problem. Next problem, which is very important point for exam point of view. In next problem, that is, we have to find out the value of the product of these two terms. Here first term is cos 3 pi by 7 plus I sin 3 pi by 7. This first term into second term cos 2 pi by 7 plus I sin 2 pi by 7 bracket square. In order to solve this problem, we have a solution. Let cos 2 pi by 7 plus I sin 2 pi by 7 bracket raised to n. Again, according to de Moivre's theorem, from this term, here power is 2, n is the power and its value is 2. According to de Moivre's theorem, we can write here cos 4 pi by 7, that is theta into n theta. Again, we are going to remember what is de Moivre's theorem? Cos theta plus I sin theta bracket raised to n is equal to cos 2 theta plus I sin 2 theta. According to this theorem, we have cos 4 pi by 7 plus I sin 4 pi by 7. And when we solve this term, or according to universe formula, we can convert this term into exponential of e raised to I 4 pi by 7. Like this, we can also convert this term into term like this, and which is nothing but cos 3 pi by 7 plus I sin 3 pi by 7. Again, According to Euler's formula, we have e raised to I 3 pi by 7. Okay. Now we have to take the product of this term with this term. We have cos 2 pi by 7 plus I sin 2 pi by 7 bracket square into cos 3 pi by 7 plus I sin 3 pi by 7. So we get value of this is this e raised to I 4 pi by 7 into e raised to value of this term e raised to I 3 pi by 7. Solve this term e raised to I 4 pi by 7 plus I 3 pi by 7. Solve this term taking I as a common. We can write e raised to I in bracket 4 pi by 7 plus 3 pi by 7. Again solve this term e raised to I in bracket this plus this 7 pi by 7 7 getting cancelled with each other and we have e raised to I pi. Okay, according to Euler's formula, this term represent e raised to I pi is equal to cos pi plus I sin pi. We know according to trigonometry value of cos pi, that is cos 180 is minus 1 and value of sin pi, that is sin 180 is 0, that is I into 0. Simplify this term, again we get minus 1 plus 0, I into 0 0 or minus 1, and therefore value of product of this term, this square of this term is equal to minus 1. In this way we can solve the problem like this, and this is for your homework. You can solve this problem in the this way or in the similar fashion. Problem for homework is there are two terms cos pi by 4 plus I sin pi by 4 plus cos 3 pi by 8 plus I sin 3 pi by 8 bracket square. Okay, now there is one more problem. Determine the modulus and argument of 3 plus 2i upon 3 minus 2i. In order to solve this problem, let us we have solution z is equal to 3 plus 2i upon 3 minus 2i. We know that we can't solve this term by usual method. In order to solve RHS of this equation, we have to multiply and divide 3 plus 2i upon 3 minus 2i. In order to solve the division or RHS of this equation, we have to multiply 3 plus 2i and we have to divide 3 plus 2i. Remember that 3 plus 2i is complex conjugate of 3 minus 2i. Solve this, we get 3 into 3, 9. 3 plus 2i, that is 6i, 2i into 3, that is 6i, plus 2 into 2, 4i into I square, divided by 3 into 3, 9, 3 into 2i, 6i, minus 2i into 3, minus 6i, minus 2i into minus 2i, plus 2i, minus 4i square. Again here remember, here and here, you have to put the value of I square is equal to minus 1. Therefore, we have 9 plus 6 plus 6, 10i minus into plus minus 4 upon this here 6i and minus 6i getting cancelled with each other. We have 9 plus 4. Why plus? Because I square is equal to minus and minus 1. Solve this, we have 5 plus 10i upon 13. Further solve this term, we have 5 upon 13 plus 10 upon 13i. Compare this term or compare this equation z. Suppose this equation, compare this equation with z is equal to x plus iy, which is the general form of complex number. Suppose this is equation 2. Comparison between equation 1 and 2, we have x is equal to 5 by 13 and y is equal to 12 by 13. Okay, now in order to determine the modulus and argument, first modulus, we have r is equal to square root of x square plus y square. Substitute the value of x and y, we have square root of value of x 5 by 13 square plus 12 by 13 square. So this term we have square of 5 is 25 upon square of 13 is 169 plus square of 12 is 144 upon square of 13 169. So this term we get 25 plus 144, we have 169 divided by 169, and solving this term we have 1, that is modulus r is equal to 1. Now we have to find out phase angle or argument. For this purpose, use the general formula theta is equal to sin. Tan theta is equal to y upon x. Substitute the value of y and x. Value of y is 12 upon 13, and value of x is 5 by 13, that is value of 1 by x is nothing but 13 by 5. 13 cancel with each other, and we have 12 by 5, or simply theta, that is argument is theta is equal to tan inverse 12 by 5. In this way, we obtain the final answer, that is modulus and argument of this complex number. Now, the last problem. Interpret this equation. What is the equation? Z mod of z plus 3 is equal to 2 into mod of z minus 3, where z is equal to x plus iy. We have to interpret this equation. For this purpose, let we have a solution. Z plus 3, mod of z plus 3 is equal to 2 into mod of z minus 3. But here z is equal to what? X plus iy. Therefore, substitute the value of z here and here. We have x plus iy minus 3 mod. That is mod of x plus iy minus 3 is equal to 2 into mod of x plus iy minus 3. Or this equation we can write in different way: x minus 3 plus iy is equal to 2 into x minus 3 plus iy. What we here do? Here we simply exchange, or we will make some simply interchange between some terms. Therefore, we get this equation. This equation can be written by different way, like this: x minus 3 square plus y square is equal to 2 into x minus 3 square, here x plus 1, some reading mistake, plus y square. Okay. Now in order to interpret this equation, take the square on LHS and RHS of this equation. We have x plus 3 square plus y square is equal to 4, square of 2 is 4, in bracket x minus 3 square plus y square. So this time we get x square plus 6x plus 9 plus y square. Solve this term like a plus b bracket square, we get this term. Then 4 into similar way x square minus 6x plus 9 minus y square. Again solve this term, we have x square plus 6x plus 9 plus y square is equal to 4 into x, 4x square minus 4 into this minus 24x, again this into this plus 36x, again 4 into plus y square, that is plus y 4y square. Again take this term from this side to this side, we have 4x square minus x square minus 24x minus 6x plus 36 minus 9 plus 4y square minus y square, and this is equal to 0. Again simplify this term. We have 4x square minus x square, 3x square, again bring this term here plus 3y square minus this 24 minus 6 minus 24 minus 6, 30x plus 36 minus 9, 27, this is equal to 0. Again solve this term, we get, take 3 as a comma, 3 in bracket x square plus y square minus 30x plus 27 is equal to 0. After dividing by 3 to this equation, we have x square plus y square minus 10x plus 9 is equal to 0. Or you can write this equation x square minus 10x plus plus 9 minus plus y square is equal to 0. Okay. Again you can write this equation like x square minus 10x minus 9. Okay, sorry. Simply x minus 5 bracket square plus y square is equal to 16. When we solve this equation, x minus 5 bracket square will be this term and this. So we make a little arrangement in order to obtain this equation. This equation is like this equation, x square plus y square is equal to r square, and this equation represents a circle. Hence, by comparison this equation with this equation, we can interpret that this equation represents a circle whose radius is square root of, that is 4, and whose origin is 5 I0 or 0 I. And every point on the circle is represent the complex number z. In this way, we can again solve one more problem, and this problem is for your homework. You can solve this problem, that is mod of z minus 3 is equal to root 2 into mod of z minus 4, where z is equal to x plus I1, and you can solve this problem at your home like this way. Okay, we shall stop here. Have a good day.